Hello and welcome to our presentation. My name is Sheila Mugala. The title of our work is Unmanned Aerial Vehicles, Opportunities for Developing Countries and Challenges. My co-authors are Dr. Dorothy Okello and Dr. Jonathan Serugunda. We are with Makerere University in Uganda, East Africa. An unmanned aerial vehicle, abbreviated as UFV, is an aircraft without a pilot on board, usually referred to as a drone. UFVs are classified according to various features such as those shown in the figure. The type refers to the mechanism of flight. There are two major types, the fixed wing such as the EB and the rotary or multi-rotor such as the DJI Phantom and Parrot. Another important characteristic is the altitude of operation. Here we have the high altitude platform UFVs or HAPs that operate 17 kilometers above the Earth's surface, and the low altitude platform UAVs or LAPs that are deployed a few kilometers above the Earth's surface. LAPs are quick to deploy and are thus suitable for emergencies such as a disaster. Other features include the size, weight, level of autonomy, and power source. These characteristics determine the payload of the UAV, that is, the equipment or objects it can carry, and the application. We are focusing on UAV applications for humanitarian and development purposes. Okay, moving on to the research objectives. Our main research objective is to present applications for unmanned aerial vehicles for developing countries, particularly for development and humanitarian purposes. Our specific objectives are to explore applications for UAVs, to investigate challenges for the applications in the first objective, and to present these research challenges. For our methodology, we use document analysis. We refer to online journals, conference proceedings, and organizational documents and websites for Africa-specific information. We next present crucial UAV applications for developing countries. We were guided by the high-level African Panel on Emerging Technologies, or APET recommendations. APET is a branch of the African Union. The following are the proposed applications. Similar to the APET report, we find that search and rescue, or SAR, agriculture, and delivery are key UAV applications. In addition to that, we propose UAVs in electric power systems. Here we focus on surveillance of transmission lines and network coverage or connectivity. In search and rescue, UAVs search for and detect single or multiple targets, such as a victim of disaster. They also track victims. Their main role is to assist rescue personnel to reach victims quickly. In our case, we maintain that UAVs are involved in all the three stages of disaster management. That is, in the first stage, referred to as pre-disaster preparedness, UAVs are used as part of an early warning system. In the second stage, or disaster assessment stage, UAVs take photos and videos for situational analysis and relief planning. In the last stage, that is the post-disaster stage, they are used for finding victims, providing communications network, and surveying. We note that the APET recommendation focuses on insurance, leaving out the disaster assessment stage, which is crucial in disaster management. Some challenges that arise when using UAVs for SAR include automatic detection of people and actions. This requires development of appropriate algorithms, the design and placement of recharging docks, since UAVs are battery-powered devices, and design of efficient control algorithms to ensure stability in noisy environment with atmospheric disturbance such as wind. UAVs are anticipated to play a dominant role in agriculture, a prominent economic activity for developing countries. They are used for many activities including mapping to determine crop and soil health, spraying pesticides, irrigation, and planting. Another important role is in Internet of Things or IoT, where they gather data from sensors. Major challenges that arise when using UAVs in agriculture include the complex nature of farming in developing countries, where smallholder farms predominate, implying that the cost of using a UAV may rise, but promising studies have been done for mapping smallholder farms in Ghana. Other challenges include automatic detection of crops, especially on a mixed farm or at different stages of growth, detection of weeds, and presentation of the acquired from the UAV to low-level literacy farmers. A UAV-based delivery system uses UAVs to deliver items. It is particularly useful for developing countries which do not have sufficient infrastructure. It is also useful to make deliveries to hard-to-reach areas such as mountains and islands. UAVs have been used by Zipline in Rwanda and Tanzania to deliver emergency supplies of blood. The scheduling and routing of UAVs for delivery determine the delivery time, coverage area, and cost. UAVs are power-constrained devices which limits their coverage area. However, existing road or rail transport can be used to extend their coverage. Other important issues include navigation in an unknown environment or without GPS and stability. Surveillance of transmission lines using UAVs. We also explored the use of UAVs in electric power systems, though our focus was limited to surveillance of transmission lines. We observed that the majority of the population in developing countries is not connected to the grid, yet power is a key driver for economic growth. Only 22% of Uganda's population is connected to the grid. With the expectation that the electric power grid will widen, we propose a low-cost, efficient surveillance mechanism for transmission lines. These determine the power quality at the end user. The UAV will be used to take photos of key components such as the conductors, insulators, and towers. The photos are then transmitted to the engineers who identify faults, or alternatively, faults are automatically detected. One major challenge of using UAVs for surveillance of transmission lines is that it is difficult to extract aerial images of a transmission line, which is a thin line against a complex background that varies from rugged terrain to continuous vegetation, as shown in this diagram. UAVs also need to be protected from the high electromagnetic fields. Network coverage using UAVs. The last application we are presenting uses UAVs to provide network coverage or connectivity. That is, they serve as aerial base stations. We note that all UAV applications need connectivity with a control center, ground personnel, and other UAVs for collision avoidance. There are 3 use cases for UAV base stations. They can provide ubiquitous coverage, in which case they support an overloaded terrestrial or ground-based station, provide connectivity for rural and remote areas, and also form a disaster communications network. The second use case is that UAVs form a relay network to connect distant users. And finally, they are used for information collection and dissemination in the Internet of Things or IoT. We need to characterize the UFV Wireless Communications network, which consists of highly mobile nodes, moreover with low power. This figure shows the UFV Wireless Communications network with both the aerial base stations and the ground base stations and their coverage areas represented by circles. It also shows the anticipated information signals, interference, and backhaul links. Other challenges. There are challenges that cut across all applications, and these include the limited size, weight, and power. There are also issues that arise when using a cluster of UAVs or a group of UAVs, such as collision avoidance, control, and communication. UAVs are also faced with security threats, including jammers, malicious attacks, and interception. Privacy issues arise since UAVs are equipped with cameras and other sensors. We also need to quantify the risk of flying UAVs over objects, and lastly, the most critical is that of regulation. In conclusion, the UAV applications presented should serve as a precursor for others that will arise as the technology evolves. We have presented the technological, safety, and regulatory issues. As part of our future work, we will address issues around a UAV wireless network. At this point, I would also like to thank IST-Africa for organizing this e-conference given the current circumstances. And lastly, these are some of our references. Thank you for attending our presentation electronically.